Okay, this is the last part of factoring. We're going to do factor by grouping. So when you have 4 terms, what you want to do, you're going to group first 2 terms and the last 2 terms. Okay. Second thing you want to do is factor out the GCF. For each group, creating 2 new terms. And the last thing you're going to do after that is factor out GCF of those 2 new terms. Okay, so let's start with this first example, example A. There are different ways that you can group. You can use parentheses. So for this first one, I'm going to use a parentheses around the first 2 and the second 2. And the reason I like 2 is because I can have a plus between. And so now I've grouped them. And now I'm going to factor out the GCF from each group. So when I look at this first group, here my GCF is x squared. So make sure you put an x squared, parentheses, and again I'm dividing everything by an x squared, which leaves an x plus 3. Now right here is your hint. This is your hint for the next group of factoring that you want. So now I'm going to go and what do I have in common between the 5 and the 15? So my GCF here is going to have to be a 5. And when I pull out the 5, it should leave me with an x plus 3. That plus comes down here, 5. Then divide by 5, I get x plus 3. And there is my other part. Now the third thing to do is factor out the GCF. Well, the thing that I highlighted is the GCF of those 2 new terms. So I'm going to factor out that x plus 3. X plus 3 is in parentheses. And then what's left over? Well, this is an x plus 3, and this is an x plus 3. So if I cancel these, I'm left with an x squared plus 5. And that's factored completely. All right, let's try the next one. Now the next one, same thing, you group the first 2. I'm going to use a little bit different way of doing it besides parentheses. I'm going to look at these 2 together, and I'll look at these 2 together. The first one I factor out, I see that I have in common a 2 and an a. So between the 6 and the 10, the 2's, so my GCF is 2a. Okay, since 2a is my GCF, I'm going to factor both terms here by 2a. Okay, so the first one, put 2a here, parentheses, 6 divided by 2 is a 3, and the a's cancel, so I'm left with just a 3x. Here I have 10 divided by 2 is a 5, so minus in between, and the a's cancel out. So here is my hint of what I want left in the parentheses over here. So over here, I have between the negative 3bx and the 5b. The only thing I see in common is a b, but my GCF needs to be a negative b. Okay. So if I divide this by negative b, I pull that b out, I wind up with a positive 3x. I take out a negative 3 here, negative b, and I wind up with just a minus 5. Okay, again, there's my nice little factor. Now I can factor out what I see again, which I happen to see again is the 3x minus 5. If I divide everything by that 3x minus 5, I am left here with just 2a minus b. Again, you can check yourself by everything we've done so far. Is to always FOIL back, distribute back in to see if you got what we started with, okay? So there's your solution for that one. So this next section is to use all the types of factoring that we've done so far if we need to. So this is going to be factor completely, and there may be more than one type of factoring that's needed. Okay, so the first thing that you always want to do, check for a GCF. Okay, it's the first thing you want to do, even though it looks like you can factor some way, but you want to check for that first. So between 8x squared and negative 32, there's two terms, so I probably have a difference of squares, or a difference of cubes. I see a square there. You cannot take the square root of 8 and square root of 32. So we're going to factor out an 8. So the GCF here is an 8. So in parentheses 8, I wrote that the wrong way. X squared minus 4. Now I have something that's factorable by difference of squares, x plus 2 and then minus 2. Let's go to example B. Can look at, do I have a GCF? I do. If I looked at all the numbers, I can divide all of those by 2. But I also can divide everything by an x. 2x out here. 6 divided by 2 is a 3. And that's an x squared minus 25 over x minus 18. Now this is a trinomial, so it has 3 terms, so now we're going to do trial and error. So we're going to look at 3. So the factors of 3 are just 1 and 3. The factors are 18 are 1 and 18, 2 and 9, 3 and 6. And because this is a minus and a minus, we know for sure that those signs have to be opposite. So we have 2x, 2 parentheses. Now with the factors of 3 being only 1 and 3, these two terms are just, one's a 3x and one's an x. Now you have to, it doesn't matter which order you put it in, now you just have to figure out which one of these we can use, okay? So again, we know that this has to be a plus and a minus. The signs inside have to be opposite. So if I try to use 3 and 6, 3 and 6 will not work because 3 can, they're both, this 3, it has a common factor of 3 for both of these. So you can't use that one. So I'm going to try 2 and 9 because they're the next closest. So if I do 2 and 9, I can't put 9 in the first parentheses with the 3x, so I have to put the 9 in the second one. Okay? So now I'm looking for a negative 25, so I'm going to put the negative sign in front of the 9, and I'll put a positive and see if that works. So when I multiply 3 times 9, I get a negative 27x. When I multiply 2 times x, I get a positive 2x. Add together, give me negative 25x. So we know this is our solution. All right, let's look at letter C. Letter C, I have 3 terms. And when I have those 3 terms, it's still trinomial trial and error. The only thing difference that you see is that it's got an x to the 4th and x squared. So if you have a 4 and 3 terms, the next one's a square, and that middle term, then this is factorable. Just remember that x squared times x squared is x to the 4th. And that's how we're going to get this to work for us. Okay, there's nothing in common, no GCF. The number in front of here is actually a 1, so I have the factors of 1, which are 1 and 1, and the factors of 9, which are 1 and 9, and 3 and 3. Okay? But instead of putting x to the 4th, I'm going to think about this up here and do x squared times x squared. Again, if I FOIL this out, x times x squared times x squared is x to the 4th. Okay? All right, so the next one I want to look at is which one of these two. Well, if this is a minus and a plus, automatically this is a minus and a minus. So one thing nice, you can put minus, minus for sure. And then now you just ask yourself, which one will make me a 10? The closest thing that'll make me a 10 is a 1 and 9. Now, factor that. Is this factored completely? Well, in each of these are difference of squares. So this one's a different squares, and so is this. So I'm not done, so I need 2 parentheses off of this one. X minus 1, square root of 1 is 1. X plus 1. Okay, difference of squares with a 9. X squared minus 9. 9 is perfect square. So it's x plus 3 times x minus 3. And there's your factor. Let's look at our last example. We have 4 terms we're going to group. First thing we check GCF though. There are no numbers that are in common in every term, and there is no variable that is common in every term. So we're just going to group. I'm going to group these 2 and then these 2. First 2 and then last 2. I see that they have an x cubed as a GCF on the first 2. So divide by this, divide by cube. I've lined up with an x squared minus 4. Again, this is your hint. So here I'm going to factor out an 8. So plus 8 x squared minus 4. There it is. So the GCF between these 2 new terms is x squared minus 4. So we divide everything by that. I wind up with x cubed plus 8. So now I look at the 2 factors I have left here. Do they have, now I determine, are these factored all the way? Are they factored completely? No. There's a difference of squares here in the first one, and this is cubes. Okay, so the difference of squares, I'm going to have x minus 2, x plus 2. Now the cubes, you got to remember, a is going to be an x, and b will be 2. Okay, so you're going to add the 2 first, so x plus 2. And then you're going to square a, subtract a times b, and then square b. Reminder that this last trinomial here is not factorable if you're using the difference of cubes or the sum of cubes.